We had swapped a big block 440 into a Scout. To do this, we had to move the engine mounting horns on the frame. Now we are replacing the 440 with a Dodge 5.9 Magnum engine out of a Dakota. Time to move the horns again. In this video, we show how we remove the horns. We show how we designed and fabricated new horns out of 1/4-inch steel plate. We go over design and fabricating 1/4-inch thick scab plates to mount those horns too. We'll show how we located everything prior to welding all of it together. And last, we show the frame and steering box reinforcing scab plates welded to the frame. Having second thoughts about the mounting of this engine, and to me, you know, if you can, you might as well do it while you can, and make it so that you feel better. A couple of things there. You see the angle on that? They're like pointed up, and like my neighbor said, for the thickness of the metal, while it's reinforced because of the distance away from the support it's on, it could fatigue and start bending down. So one of the options is to make this metal thicker. And the other thing was, these have been moved once to put the 440 in. You can see where we cut. Well, I didn't do it, a neighbor did it for me. Cut this and then welded that seam where we cut it back up or ground it off, and same thing on the other side. So you can see that the motor mounts are back a little ways. This one looks like it's back a lot. I guess that was because the way the 440 was designed, I'm not sure. But in any case, I'm thinking about moving these back up, and definitely on this side. And at the same time as I do that, it looks like they used to be lower. So lower this down and move it this way. The same thing on this side. It's actually tilted a little bit this way too. So level it up, move it forward. I don't know if I move it forward this far. That seems like an awful long way the other direction. And then level it off as well. That would put these motor mounts back in the original position, so if anyone ever wanted to pull this engine out and put a stock Scout back in, they could. And since I'm going to remake these brackets or improve upon them, that shouldn't be an issue. One of the things you can see is that right now this is in a little ways. On this side it's further. So here's the back of the bracket, the stock Scout one. Here's mine. That's a whole bunch of inches. So if I move it this way, it'll actually center this better on here. And same thing on the other side. This side's closer to being right where this is, but again, this isn't centered in this. So if I move this the 1.5 inches to here, that puts this almost in the center of this, and I don't see anything wrong with it, except for maybe the fact that I've got to grind and weld again. And like I said, while I'm doing that, the engine will drop, one, because I'll move the horns, the ears on the chassis down and forward and down, and two, because I'll take that tilt out of the side mounts when I'm making those stronger. So far our temporary engine mount is holding up pretty well. Got the engine mount completely off of this side, and this side isn't resting on it, obviously, but I still have to unbolt it. Have the engine mount that originally was here, the Scout mount that we've moved back here and up, cut out, and what I did was I ground a flat area right near the top, a groove, to run the saw through. I didn't use a cutoff wheel. I'm using a saw to try and get a nice flush cut, even cut, and not take away any metal, the least amount of metal, just the width of the blade. I don't have to worry about it. So with that done, and the old welds, I can see where I ground them down. This will go now here, and you can see behind it where I had moved it when I put the 440 in. So now we're putting it back in the original location right here. And it actually works out to be directly underneath, so that the hole in the motor mount is centered, but I think I'm going to move it, the engine, a little bit forward anyway, 1 inch. The other side, you can see I ground a groove in it for the saw blade, help guide the saw blade, and I have to cut this side off. I'm trying not to have to take the header off, but it's in the way on this one. It wasn't on the other. So this side I may use a cutoff wheel. I'll use a 16th one, so it's very narrow, and I may use the one in the Dremel. I've just gotten some new ones in that are diamond wheels, so I'll have to see how they work compared to the grit ones. So I have to cut this one off, and then this one will move. This one will move all the way up here. We're about ready to drill the holes for our scab plate and the new motor mounts we're making to replace the ones we cut off the frame, and they had been cut off and rewelded before, so there was a lot. They were not as wide as they used to be, and I wanted to put them back to the stock location. But this is about how we're not going to show you cutting this metal out. It's 1/4 inch thick. Cut it with actually with a jigsaw with a bimetal blade to get that nice arc. Then I went back with a flap disc and made it to exactly what it should be. And I put the two of them together and made, they don't have to be identical, but I made them as close as I could. Then I made a cardboard template and used that to be able to center punch where the 3 holes need to go on these. Now, the holes on the new 1/4 inch plates that are replacing the 1/8 inch motor mount, we center punch those as well. That was fairly easy. I just put it on the end, found the center, and then center punched them. For this, I used a cardboard template and center punched them. Now the important thing is I'm drilling through a 1/4 inch. I want them to be straight, especially here, because these are getting bolted to the frame rail, so the bolts are going to go all the way through the frame. So if they're tilted, it's going to be a pain when it gets to the other end. So we want them straight. So how are we doing that? Something you may have lying around. This is just one of the accessory brackets off an engine. I'm not even sure which engine it's off of, but it has a nice flat surface. It has perpendicular holes that are the right size. The drill fits right into them, and what I did was I marked the edge. I took the center punch and located the drill on it, and then well, actually I push it through here first. Then I locate the center punch, and I can't do it when I'm holding the camera as well, but well, maybe I can. Put the tip of the drill in there and lower this down, and I marked around it so I know it's in the same position. Now I'm just going to put a C-clamp on this. So with a C-clamp on and this bracket flat against the 1/4 inch plate, I've got the drill at 90s in 2 planes. Now, it's easier to do this like this than with the drill already attached. So you get it all set up, you make sure it's in there right, then you can attach your drill and drill the hole. I snug down the drill on the drill. I clamp down this bracket to a frame, and then I also put another clamp to keep this from trying to spin when the drill, from the torque of the drill cutting into it, so it can't flip out and move out of position. So we finished drilling through, and our alignment marks are still exactly where they were, so the fixture didn't move. There's a little bit of wobble maybe in side of this. It's not a hardened special steel to hold the drill bit, but it certainly is it certainly does the job. Well, first scab plate's done, 3 holes drilled in it. You can see they're nice and round, didn't wander, look really good, nice straight flush holes. And more importantly, now this bracket is going to go over, or going to go underneath that bracket there. So this is really going to reinforce where the steering is, but it fits perfectly. It fits perfectly over those bolts. They're definitely centered. And then we have the extra bolt back there. That'll come through as well. So this will be fastened on with 3 bolts on both sides. There's the 3 holes here, but there's no power steering on this side. And we'll tack it as well. Second plate, holes all drilled, and here you can see these aren't bolted in, these are just the right size to see if everything lines up, and it does. And you can see I got this nice section up here for welding along the top. I left the same thing along the bottom. There's about this much on the bottom. But this is 1/4 inch plate, and with 7/16 grade A bolts, that's pretty much going to be held in anyway. But we're doing that to strengthen the frame. In order to get these holes on the frame perfect, we used a piece of cardboard template that we fits exactly the frame rails, and then we held it on the one side and used the holes on the other side. And I can't do both, let me do this. And then I put a pencil through and then just scribed it on the back of the piece of paper I had. And this gave me great, exactly the size, perfect location, where they should be. And then I just took I just centered each one and put a center punch in it. Then I used that on the steel plate, center punched the steel plate, then drilled the holes with the jig we showed you. And this, we've ground all the mill scale off. We're getting ready to weld it up. We're fabricating replacement brackets for the original ones instead of welding them back on, because these have been cut and welded on twice already, and some of the material it has here is missing. Don't stick out. It'll keep getting closer and closer. See how close that hole is. There should be at least a 1/4 of an inch behind that. But we're making it of thicker material for one, because of the stress possibly of the larger engine. The weight, it's actually going to be lighter, but the torque may be greater. Also, one of the things we wanted to do or mention is this is thinner material, but it's stamped and engineered. So you see this little depression here and the curves here? That all adds strength to this, a tremendous amount actually. Just like when they stamp the grooves or the recessions in the floor. Believe this is also to allow for drainage underneath here. It looks like that's what it did, but it certainly added strength, and the pattern did that. So while we're using thicker metal, that doesn't mean it's stronger than this necessarily, so you have to account for it. So the fact that they made the wideness at the bottom and didn't come straight down also to me suggests that that's part of the strength, is distributing the weight outward instead of all straight down. So we want to duplicate that at least. So what we did was we put this on a piece of paper and we marked it so we could get the angles. And I used a protractor, and this is 110 or 55. 55 and 55 is 110. Then I took a piece of paper and cut it and tried it, and then I transferred it to cardboard. And if we put two pieces of cardboard that are cut at a 55-degree angle, they match what the original bracket was like. So now we can use this cardboard and transfer it to the edges of the 1/4 inch. So we'll grind a 55-degree angle on each side of the 1/4 inch, and we'll grind a 55-degree angle on the back of the 1/4 inch plate that's the top piece. It goes up here, and if we do that, then we'll end up with 1/4 inch thick with this shape and dimensions. And we've already put the holes in that match the holes in here. We didn't put the back hole in because we're not worried about the drainage. Now if you wanted to put the old style scalp mount on, it'll go right in there. If you wanted to use any one of these, you could, if you just want to use a single mount, so it allows for location. But this will allow, once this bracket gets mounted to the new scab piece we made, like this will allow for the engine, a Scout engine, to be put back in the original position and attached to this super thick plate that we've made. We've tacked one of our brackets, new motor to frame mounts, and there's some gap and stuff, but that's fine because we need these. This is 1/4 inch. Our TIG welder possibly could do it, but it's going to kill it, and we want to make sure we have really good welds on this. So we TIGged it in place so that a friend who has the big welders can weld this nicely for us. It'd be a lot quicker for them. We took the paper that we had with the holes, 3 holes, put it on the frame, and what looked like was the measurements for where the welds used to be, and transferred it then we put the bracket we still have on the marks and our new bracket, and because of the thickness we have to allow for that, plus our new bracket's longer. I'm going to weld on the ends, but this should work well. Same thing on the other one. And we measured from hole to edge, hole to edge, hole to edge, and we marked that on the chassis, and then we marked it on our template paper, and then we marked it on here. I think we're as close as you're going to get to being to where the original was, and probably the originals were not exactly the same spot on every chassis. So, and what we did was we also first we marked it with a magic marker, the position, and then on over the marker line I ground in a little die grinder a little bit, marks for where it should sit just inside of, plus I have alignment marks on it, and this is B, so this goes with the B motor mount, and on it has the scribe marks as well. So once that's welded, and you just line it up just inside with the scribes aligned, and then it can be welded in position there. I wasn't sure too whether a friend would want to weld this all together, or weld this up first and then weld it to this, or secure them to each other and then weld them. So I'm leaving that up to him, but I put the scribe mark so he'll know where it needs to go. And these are measured. There's one on each side. I measured from the bottom up here, and from the top down from here to here, and then from the bolts to the edge, from the edge to the edge of this, and the edge of this to the edge of that, so that both sides will be the same. We're about ready to put our new scab plates with motor mounts on. We ground this nice and clean, and then this is stainless steel paint. I put a little bit of tape on here because I want bare metal so we can weld the top, even though it's going to be held on with bolts as well. And the plates themselves, here it is, all welded up. Our friend, who's a great welder, welded the inside and the outside. I attacked it so he knew where to do it, and then I sprayed this with the stainless steel paint as well. And you can see this is bare metal up here because I did the same thing with the tape. I taped it so we'd have an area we could weld to. And I painted the back side, so this would be stainless paint against stainless paint on there, bolted and then welded on the edges. There's a shot with the just got this loosely on now, the bolts. So there's 3 bolts, 2 in the front, 1 in about the middle. It's right underneath the mounts, the engine mount horn, which is great. But then again, like I said, we're gonna run a bead weld on the edges. I may just run small, like 2-inch ones. I don't think we have to weld all of it, although I did put the paint on both sides so that we don't get rust and stuff. So if I don't weld all of the top edge, I'll probably put some sort of a sealer to make sure that the rust doesn't start forming in between. You can see we're pretty close to where the engine is, which is great, which is what it should be. And I got to do the other side. For this side, we had to take off the just a special bracket reinforcement that was on there for the power steering. This is great because this other bracket is going to add even more strength to this side for the power steering, or for the steering box. And then we'll also put this back on. We painted this with stainless steel paint too. We'll put this back on over the plate, and this plate on this side will also be welded, hence our putting tape on there. Our mounts are ready to be stick welded on, but it's been cold out, so the frame itself is rather cold. It's wasn't freezing last night, but it was in the low 40s. So what we've done is we've got a propane heater in our little thing, and we're going to try and warm this up. And it's supposed to get up to 50 today anyway, so hopefully we can get this metal back up to realistic temperature. You don't want it really cold, even with a good welder. And because of where it is in the position and the paint we have on it, I don't want to put a torch on it to heat them up. So we'll do this to get them up to basically room temperature, quote unquote. Our friend came over and welded the plates to the frame for us using our TIG welder. We had 220 out here for it, but he ended up using 7014. He ended up using 7014 rod. We had 1/8 inch and 3/32. He used the 3/32 on this, and because he was using the thinner rod, he was running about 90 amps. I was watching it, so might have got away with the 110, but it was probably better. He said it was super smooth welder. It was just one of the smoothest welders he's ever used for the IGBT type. One problem, or one things he noticed, is that the Scout frames are two-piece. They're U's over each other, so one U facing up and one U facing down. And so this is thin wall here, so he didn't feel comfortable welding underneath here into this because he was afraid it might burn through or balloon, as he put it. And so I said, that's fine. This is bolted on. It's welded on 3 sides. The bottom will drip out, so there's no problem there. Plus, we can seal it with a sealer. On the other side, same thing. Welded all the way around and then over the top. I'm very happy with it. And now we have these mounts in, and we painted them with stainless steel again. Stainless steel coating. And then we'll put Rust-Oleum black gloss or semi-gloss enamel over the rust one. We're very happy with that. We've used that on all our frames, and it seems to last forever. And we haven't seen rust coming through it. But now we have the holes, and these heavy-duty brackets now are in the same place where the original Scouts were. So if anybody wanted to, they could, I don't know why you would want to. We won't. Take out the 408 and put an original Scout engine back in here. This is our redone, modified motor mounts. You can see there's a little bit here. That's where we welded on the extra thickness to make this entire thickness 1/4 of an inch thick. So now it's got a 1/4 inch thickness. Also, for back here, the one that's hard to get to, we actually welded the nut on. And we painted this with stainless steel paint, steel it, and then we painted it with the industrial or the tractor supply International Harvester red. One other note, the mounting hole matches up with the hole in the horns, centered, so that we could technically put International Harvester motor mounts back in, and that could slide over the pin, except we've chosen not to do that style. Here's a shot of the horns, all painted and mounted. The rubber motor mounts we made from the mallets, the redone engine brackets, engine mount on both sides.